Okay, this is lecture 6 on solubility equilibria. We'll continue whatever we discussed in the last lecture. See, if I add silver chloride, solid silver chloride in pure water and solid silver chloride in solution containing 0.01 molar KCl, and if I add silver chloride solid in 0.1 molar KCl, okay, in which case solubility of silver chloride is maximum. Listen, in the last class I have told you, here we have only pure water, here we have 0.1 molar KCl which contain chloride ion, which is a common ion. Here we have 0.1 molar KCl which contain the chloride ion, it's a common ion. In presence of common ion, solubility gets suppressed, solubility gets reduced. Okay, the last class I told you. So, solubility in pure water, let me take it as S. Solubility in 0.01 molar KCl, let me take it as S prime. Okay, this is solubility in 0.01 molar KCl. This is solubility in 0.1 molar KCl. Okay, here we have common ion but concentration is low. Here also we have the same common ion but concentration is high. As the common ion concentration increases, okay, or if the addition of the strong electrolyte, right, the concentration of the addition of strong electrolyte which containing common ion, if that increases, what will happen? Solubility gets reduced. So keep this point in mind. Solubility in pure water is high compared to solubility of sparingly soluble salt, right, in presence of a solution containing its common ion. Okay, so this is what we discussed in the last lecture. Now, okay, then what is meant by the ion product? Ion product and how it is related to solubility product. Suppose I'll take same silver chloride, so a nice example. Suppose I'll take silver chloride, okay, which is present in solution. Okay, suppose if the solution containing silver ion plus chloride ion. Suppose if the solution is unsaturated solution. Okay, in unsaturated solution, which means you can dissolve even some more amount of silver chloride. That's the meaning for unsaturated, right? Unsaturated solution means in this solution you can even dissolve some more amount of silver chloride. Okay, in unsaturated solution, listen carefully, the concentration of silver ion into the concentration of chloride ion, okay, the product of the two concentrations called ionic product. This ion product or ionic product is less than solubility product of silver chloride. So if the solution is unsaturated, then the product of the two concentrations will be less than solubility product. Okay, now suppose if the solution is saturated, say, suppose I'll take another solution, right, containing silver ion, which is a saturated solution. Okay, saturated solution of silver chloride, which contain silver ion and chloride ion. Since, see, if it is a saturated solution, then concentration of the silver ion into concentration of the chloride ion is equal to the solubility product. Okay. Now, observe carefully. If this is called ion product or ionic product, if the ion product or ionic product, if it is less than the solubility product of the solid or the sparingly soluble salt, then we do not get any precipitation. No precipitate is formed. Okay, silver chloride never settled down as solid because the solution is unsaturated. So I can say another way, the ion product is less than the solubility product. Keep this in mind, whenever ion product is less than solubility product, we never get any precipitate. Okay, then what about here? Here we have a saturated solution where the ion product is exactly equal to solubility product, here also no precipitation occurs. Here also no precipitation. Okay, the solution contains silver ion and chloride ion, no precipitates form. Suppose if I take some amount of water and if I add silver ion and chloride ion through some strong electrolyte, and if the product of the concentration of silver ion and the chloride ion, if this product exceeds, see, you just calculate silver ion from one strong electrolyte and chloride ion which is introduced from other strong electrolyte. Okay, if the concentrations of the product of concentrations of these two, suppose if it exceeds solubility product, if ion product exceeds solubility product, then we get precipitation occurs. Okay, precipitation occurs. Okay, so for a salt to precipitate, this is very important, ion product should be greater than the solubility product. Okay, this is the idea we are going to utilize in the discussion of qualitative analysis of basic radicals. Okay, yeah, keep this in mind, very, very important. Okay, now we'll discuss about the qualitative analysis of basic radicals. Qualitative analysis of basic radicals. Okay, what are basic radicals? They are nothing but metal cations. Generally, they are metal cations. Okay, even ammonium ion also comes under basic radical, but generally metal cations are called as basic radicals. Okay, now we classified these metal cations into different groups. Okay, and different groups will form precipitate, right, with the different reagents. Okay, and the groups are arranged in a very, very systematic manner. Okay, the arrangement is actually based on the solubility product. Okay, the solubility product values, right? Yeah. So first I'll take group 1. Group 1 contains metal ions like in group 1 we have Ag plus ion, Pb2 plus ion, mercurous ion, etc. Hg2 2 plus. Okay, if I add dilute HCl, to the original solution, you know very well, if you want to identify basic radical, what we should do? Take the salt, dissolve in pure water. Okay, we should form what is called a salt solution. Salt solution. If it is not dissolved in water, you have to dissolve in dilute HCl. Okay, it depends upon the salt. Suppose I have a salt solution. If I add a dilute HCl in that salt solution, then these ions get precipitated as their chlorides. So silver get precipitated as silver chloride, lead precipitated as lead chloride, and mercurous ion precipitated as Hg2Cl2 mercurous chloride. Right, now the question comes, why these metal ions get precipitated here? Why not others? Okay, yeah, in group 2 we have cadmium ions, we have Cu2 plus ions, we have mercuric ions, right? Bismuth, we have bismuth, right? Many ions are there, even mercuric Hg2 plus. These ions are available in group 2. Okay, these ions can also form chlorides if you add dilute HCl, but the chlorides of group 2, group 3, group 4, group 5, okay, these metal ions, they are chlorides, okay, for which the solubility product value is very high. Keep this in mind. If solubility product is very high, then they dissolve freely in water. So those chlorides, right, chlorides of these metal ions, group 2, group 3, group 4, their solubility product is so high, so they remains in the dissolved state. Whereas Solubility product of silver chloride, lead chloride, we give the values at 25 degrees Celsius. The values are 1.8 into 10 to the power minus 10 for silver chloride, very low. For lead chloride, it is 1.6 into 10 to the power minus 5. And for mercurous chloride, it is 1.3 into 10 to the power minus 18. See the values are very, very low. These are all solubility product values. Since solubility product values of these chlorides are very low, these chlorides get precipitated. Okay, they get precipitated when we add dilute HCl. Okay, so the ion product, concentration of silver ion in the salt solution and the concentration of chloride ion from dilute HCl, the product value will exceed the solubility product, so that these get precipitated. Whereas the chlorides of other metal ions, other groups, their solubility product value is very, very high. Okay, so their chlorides remains in solution, they never form any precipitate. Okay, then now let me come to group 2. See, in the group 2, we pass what is called H2S, right? When we pass H2S, listen, we have salt solution. Let me write simply SS. SS means salt solution. We have added dilute HCl in this already. For group 1, we have added. Suppose in group 1, we did not get any precipitate, suppose. Which means there is no group 1 metal ions. Okay, if there is no precipitation, we will take the same solution which contain salt solution dilute HCl. In this, we should pass what is called H2S. H2S. If we pass H2S, listen, H2S in pure water, in the last lecture I told you, H2S in pure water will give more concentration of or high concentration of sulfide ion. But in the presence of HCl, the concentration of sulfide ion, right, S2 minus is extremely low. Extremely low concentration. Okay, with this low concentration, right, only these metal ions whose sulfides of these metal ions, okay, their solubility product values are extremely low. Only these metal ions get precipitated. Okay, so let me write here. What is the solubility product values of these sulfides of these metal ions? Let me write here. For bismuth, Bi2S3. For bismuth, the value is 1.6 into 10 to the power minus 72. Observe this value, extremely low. Okay, since this value is very low, even very low concentration of sulfide ion can precipitate the bismuth as sulfide, bismuth sulfide. Then cadmium sulfide, whose value is 8.0 into 10 to the power minus 27, extremely low. Right? And copper sulfide, whose value is 6.0 into 10 to the power minus 36, very, very low. See that. Then mercuric sulfide, the value is 1.6 into 10 to the power minus 52. See the values. Their values are extremely low. That is the reason why even with the low concentration of sulfide ion, these metal ions get precipitated. Okay. Actually, in group 4, we have nickel and zinc, right? Manganese. They are also get precipitated as their sulfides. But see the solubility product value for these sulfides. For nickel sulfide, the value is 3 into 10 to the power minus 19. For zinc sulfide, the value is 1.1 into 10 to the power minus 21. And for manganese sulfide, the value is 2.5 into 10 to the power minus 10. Now compare this value with this. See, these values are somewhat large. These values are extremely low. So, even if the nickel ion, zinc ion, manganese ion are present, they never get precipitated in group 2. Why? Because concentration of sulfide ion is extremely low, okay, which is insufficient to precipitate nickel ion, zinc ion or manganese ion at group 2 stage. Okay, at group 2 stage, concentration of sulfide ion is extremely low. It can precipitate only these metal ions because their sulfides are very, 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 very low compared to this. See, just compare these values. 10 power minus 72, 10 power minus 52 is extremely low value. Okay, so this is the reason why not, we can say, ask this question. Why not group 4 metal ions get precipitated, okay, while doing group 2 analysis? The reason is that for group 4 metal ions, the solubility product of their sulfides, is somewhat large. Okay, so since their values are large, the sulfide ion concentration is insufficient to precipitate these metal ions. Okay, I hope this thing will clear to you. Right, I stop here. We'll continue the next lecture.